So, good evening, guys. I'm Tutor Benny. So, we are going to go through a certain problem on equivalent resistance. So, this is our problem on the board. So, we have been asked to determine the resistance across AB. So, now, the resistance across AB is simply the equivalent resistance as a result of all these resistors in our circuit. So now, there are important things that we must know for us to be able to solve this problem. And what we need to know is we should know how to identify resistors in series and resistors in parallel. So now, how do we identify resistors in parallel and the resistors in series? So we say resistors are in series. Take for example, we say the resistors are in series. The resistors are in series if they share a single node. So let's say if this is R1 and this is R2. So these two resistors are in series because they are sharing a single node. So now, this is the node we are talking about. So this is the node which is being shared by these two resistors. So mind you, a node is simply a point of interconnection between what? Circuit elements or between branches. Yeah, so the circuit element or the branches. So this is where these two resistors are being connected. So this is a node. So we say these two resistors are in what? Are in series. And to calculate their combined resistance, we simply say R1 plus R2. That is the combined resistance. Now, what of parallel arrangement? So two resistors are in parallel if they share what? If they share the same two nodes. So take for example, if we have this, and again we have this resistor. So this is a node, and this is a node, because this is where the terminals of these two resistors have been what? Are being connected. So they are sharing the same two nodes. So this node and this node. So we say these two resistors are in parallel. And to calculate their combined resistance, we say it is R1 times R2 over R1 plus what? R2. This is how we go about it for us to calculate the combined resistance. So we can go ahead in solving now this question. So to solve this question, we need to identify the resistors that are in series and the resistors that are in what? In parallel. So to start with, for me, I am able to see that I'm able to identify that the 5 ohm resistor and the 20 ohm resistor, these two resistors are in series. I mean they are in parallel. They are in parallel. As you can see, they are sharing these two nodes. So they are sharing these two nodes. So we can combine them. So we say the 20 ohm resistor is in parallel with the 5 ohms resistance. So in this case, so we are going to come up with a combined resistance. Now we are going to have so many errors. There will be a lot of errors in this problem. So I will be numbering them. So in this case, I will say R1 is the combined resistance between the 5 ohms resistance and the what? The 20 ohms resistance. So we say we have got 20 times 5 over 20 plus 5. So what do we get? So we get something like 100 on top over 25. But this is equivalent to 4. So this is equivalent to 4 ohms. So we can redraw the circuit. We can redraw the circuit now that we have a single resistor here. We have a single resistor, the 5 ohms resistor and the 20 ohms resistor are combined. So let us redraw the circuit. So redrawing the circuit, what do we get? So we get a circuit which is going to look like this. So this is the circuit that we get. So we have here is the 4 ohms resistance. This is the 4 ohms, this is the 1 ohm. Now guys, before we can even go any further, this 4 ohms resistor is in series with the 1 ohms resistor. So we can add these two according to the rule of series arrangement. We can add so that we have a single resistor of what? 5 ohms. So what we are saying is we have got now R2 of 1 plus 4. So this is equal to 5 ohms. So we have a single resistor. We have a single resistor that side. So we maintain this is A and this is B. So here is 18 ohms. Here is 9 ohms. Then this is 20 ohms. Then this is 2 ohms. Here we got 5 ohms. So what else should we do? What else? So if we can see, if we are able to see, this 20 ohms resistor, the 20 ohms resistor is connected to this node. At the same time, it is connected to this node, where the 5 ohms resistor is also connected. So the meaning is that these two resistors are connected to the same what? To the same two nodes. So they are in what? In parallel. So we can perform the parallel arrangement. So performing the parallel arrangement here, what we have is R3. So we are calculating R3. So R3 will be equal to the combined resistance of this. So now I'm sure I got this answer before, of the combined resistance of the 5 ohms resistance and the 20 ohms resistance, which was 4. So I'm just going to copy that answer. So we have got a 4 ohms resistance. So it is still here. So I will redraw the circuit and it is going to look like this. So in other words, you can have something like this. Then we have a resistor somewhere here. So this is A and this is B. 16. We have 18. This is the 2 ohms resistance. Then this is 9 and this is 4. So if this is 4, so again the 2 ohm resistor is in series with the 4 ohm resistor. So we can add those two resistors. So according to the series arrangement method, so we say R4, our R4 is equal to 2 plus 4. So this is equal to, we have the 6 ohm resistor. So we can replace. So replacing, I'm going to have the 2 ohms resistance. Here I'm going to replace with the 6 ohm resistor. So as we can see, these resistors, they are again connected to the same what? To the same two nodes. So the 3 resistors are connected to the same what? 2 nodes. So down here we have a single node. Even this side is a single node. So we have common point of what? Of contact. So the point of contact is what? Is common. So they are connected to the same what? To the same 2 nodes. This is node 1 and this is node 2. So the all of these resistors, the 18 ohms, 9 ohms and the 6 ohms resistor, they are in what? They are in parallel. So we can perform the parallel arrangement method So to perform the parallel arrangement method, what do we get? So what we get is, so the parallel arrangement method that we are going to use when dealing with more than 2 resistors, it is R equivalent is equal to, so R equivalent is equal to, we have got 1 over R1 plus 1 over R2 plus 1 over R3. Yeah. So the inverse of this. So that is when you are dealing with more than 2 resistors. So now, if you have 4 resistors, you can add the fourth one. So, but me, I'm dealing with 3 resistors being combined in parallel. This is 1, 2, 3. So meaning, I ended on R4. So I'm going to say R5 is equal to, so we have, so to make a difference, I can use letters. Let me try to use letters because I have used numbers earlier. So I can say Rx, Y, then Z. So it's one and the same thing. So R5, so R5 will be equal to, it is 1 over 18. I have the 18 ohm resistor plus 1 over 9 plus 1 over 6. The inverse of this is in R5. So I'm sure I can lab this part. So I can lab this part. So what would be the answer? So the answer is 1 over 18 plus 1 over 9 plus 1 over 6. So the inverse of this. So I'm getting R5 as 3 ohm. So if I redraw the circuit, now that all these are combined, I have combined them. So I am remaining with a single resistor here. So I have the 16 ohms here, then all those are combined. Then I have A, B, then 16 ohms, then we have 3 ohms. So what we have been given in this circuit, we have been given the resistors like this, but we want the total resistance across these terminals. So if you have observed something in my calculations, I have maintained this part. So up to this point, so what I'm going to remain with now is the final answer across what? Across AB. Is the equivalent resistance, which is RAB in this case. So we are saying RAB is equal to, I have remained with 2 resistors which are in series. So we have, it is 16 plus 3, which is equal to 19. So we have 19. So hence my RAB is equal to 19 ohms. So this is the final answer. So as simple as it is. So you guys, remember to subscribe and follow my YouTube channel. Thank you so much.